Thanks, Peter. Not only do you get to hear us speak 33% faster, you get to enjoy accents that you can't understand. So, okay. I might start with a little story. So in 1951 in the snowy mountains of Australia, the Australian government employed 100,000 men to construct what is still the largest engineering project in the history of that country. And that was the Snowy Mountain Hydro Scheme. And in post-war Australia, we had a massive shortage of materials and labour, which presented a housing challenge to what we were going to do with those 100,000 men. And a young Dutch guy arrived from Europe and he saw a business opportunity. He promptly founded a building company on the back of a contract to build nothing more than 200 houses. So that was a tiny contribution to that massive project. But the interesting thing about those 200 houses is that they were prefabricated using timber frames that came from Finland. And the plumbing came from England and the roofing came from Belgium, and all of that was freighted to the other side of the world. And the company he founded has since gone on to deliver some slightly more well-known projects, such as the construction of the Sydney Opera House and the New York 9/11 Memorial, and some larger scale projects like the Barangaroo project in Sydney. And the reason I tell this story is it would seem that we've now gone full circle because we're once again exploring the use of timber and prefabrication to solve precisely the same challenges that our founder would have understood. And the culture of innovation that he imparted some 65 years ago has really led us to this exploration of mass timber, and particularly CLT, for a range of projects around the world. Cobalt Place in London hasn't had a lot of coverage in this conference, but it's our largest use of CLT to date, and that was for 200 apartments. That was completed last year. The Forte Living project in Melbourne has had a lot of coverage in the past because in 2012 it set the height record for CLT in a residential building at no more than 10 stories, which I'm happy to say has been surpassed a number of times since. And here in the US, our business in the last few months has completed a hotel at Huntsville in Alabama, which I believe is the largest US CLT project to date. Unfortunately, it's a very difficult one to visit because it's on a Department of Defense site. And we've also completed a very large public library for the City of Melbourne, which was actually a larger building than the Forte project, but lying down on its side, so it doesn't quite capture the world's imagination the same way. But it certainly captured the imagination of the 60,000 people per week who visit that building. For every one of these projects, there's been a technical driver, an actual reason why we wanted to use a different building medium. And mass timber provided the answer in each instance. So the Forte building, you may already know, it was located in an area with very poor ground conditions. And the bedrock's some 60 to 70 metres down in parts of the site that we're developing. So piling costs were extremely high. And we were looking for any kind of lightweight solution that could address those piling costs. And really, this was our first experimentation in a lightweight building. We also used the Forte project to test the market response. We wanted to understand if customers and the finance institutions would actually buy the concept of a home 10 stories up in the air made of giant pieces of plywood. And very fortunately, they did. And the library, it had its own challenge in that we wanted to build it on top of a 100-year-old wharf structure, and we didn't really want to do any work on the wharf. Like most developers, we're lazy and we're tight with our money, so we thought if we could reuse that wharf without spending $1 on it, that was a great thing. And the CLT enabled us to do that. We got a 3-story building sitting on top of a 100-year pile set. The hotel is very interesting in terms of its requirements. Because it's Department of Defense, it needs to provide a level of ballistic resistance, force protection for the armed forces personnel that will inhabit that building. And it was not something we expected of CLT, but tests have proved that it's actually a phenomenal material for ballistic resistance. So every one of these projects has taught us numerous things about working with CLT, and it's interesting. It's a new, yet it's a very old medium in terms of the timber that it's made from. And you've heard a lot of these things over the last day or so, and you've seen it on the tour, and you've heard it elsewhere, that there's great benefits in terms of the carbon life cycle analysis and the speed of construction, and how quiet the construction is, which is of great use if you're working in a dense existing neighbourhood. Fantastic interface with other trades. The other trades working in the building really love it. It's great to work with. So the positives are many, and the process is really very simple. In fact, we've always been looking for the smoking gun or the problem we couldn't foresee, and yet there hasn't been one. provided you do your homework, which I think is important to stress. This is a different material, and you really need to understand how the material works. But there's actually a bigger reason why we should choose to go down this path and deploy mass timber or CLT. And it's this. We genuinely believe there must be a better way of delivering buildings. That the construction industry, as it stands, is wasteful of the resources that it utilises. It's even harmful at times to the environment and to the people who work within it. And that buildings that the industry produce are too often less than what they could be. And human beings, as we know, can create absolutely magnificent buildings capable of enduring for centuries. And we all have our favourite examples. But the vast majority of what comprises our built environment is of strictly average quality and limited life expectancy. And every year, as you know, costs rise and quality really doesn't. And customer expectations also increase, but productivity doesn't. And regulations increase, but that gives us more complexity, not better results. So we're really interested in exploring different building mediums and different methodologies and different business models. And that includes things like prefabrication, and digital manufacturing, and mass timber, because maybe they're a part of the future of delivering better buildings. And if they're not the answer, they're at least a step in the right direction. And I think failing to take a step forward is to accept that we will become ever more unfit as an industry. And that's a failure to evolve. And this graph, and I promise you it's the only graph I've got in this presentation, it tells you about the woeful state of housing affordability in Australia. And unfortunately, that's not a problem confined to that country. It's a problem in almost every country on earth. It's present in this country. And unfortunately, we need to talk about housing because it addresses one of our most fundamental needs, to have shelter. Because it's such a fundamental need, economists track housing data closely, but rest assured the same problems apply to all the other building topologies that we're involved with. And I think it's interesting to reflect that a smartphone, which is a device that didn't exist 2 decades ago, it's now been developed and refined, and the cost has been reduced to the point where the phone company will give you one when you sign their data contract. And the same things happen with cars. They're now more sophisticated than they've ever been. And yet relatively they're also at their cheapest point, but they're sold now with a 7-year warranty. Meanwhile, our industry makes no discernible shift in its basic mode of production, and the cost of labour and the materials it consumes marches ever upwards. The property industry response to this problem of affordability, particularly in urban areas, is to create smaller products. If there's less floor area, surely it will cost less, and therefore affordable equals small. And there is a point where this equation simply doesn't work, and we're now reaching that point all around the world. So we think we've got a solution, and our theory is very simple. If buildings were easier to build, they would most probably be faster. And if they were faster, they would certainly be cheaper. And if they were easier, faster, and cheaper, we can make them better. Easier begets faster, begets cheaper, begets better. And so if mass timber looks like it can achieve the first objective, to be easier, then the rest seems to hold true as well. And that's pretty much been our experience to date with the projects I ran through before, that a well-designed mass timber building is easier to build, it is faster to build, it can be cheaper to build, and it can definitely be better. So what drives all this inefficiency in our industry? Is it a issue of spiralling labour shortages? Well, potentially, but let's consider lessons from some other industries like car manufacturing and steel manufacturing. And you may be familiar with lean manufacturing or lean construction, lean thinking, the concepts behind it. And central to any lean improvement effort is the identification of wastes. And wastes not just being physical wastes that get placed into a garbage receptacle, but essentially anything that does not add value to the customer. And construction remains one of the great untapped opportunities to search out and eliminate the forms of waste that lean teaches us about. And if you have any familiarity with design and construction, you will know that all of these wastes exist in abundance in how we design and develop buildings today. At any construction site, we carry more inventory than we immediately require, often haphazardly placed around the project, because it's better to have the materials on site and ready to use than be caught short, right? Which leads to damage and to loss and to other wastes like movement. Movement of those same materials because they're in the way of the jobs to be done. Movement of workers looking for those same materials, wondering where they were moved to. And the waste of waiting, which is an enormous waste in construction, and it's easily identifiable. Look for any two guys with their hands on their hips, staring upwards at the ceiling, discussing a problem. You've got the waste of waiting. So lean's been talked about in construction for a long time, but it hasn't really taken hold. And the answer probably rests in whether or not we can approximate a manufacturing environment on a construction site. And many of you know the job site is an ever-changing work front with less than optimal field conditions. Processes vary from one day to the next. And the one major element of a construction project that has been inherently difficult to remove from the field is the primary structure of the building itself. Precast concrete and steel have been used to some effect, but the extent of work that remains to be done on site is usually significant. Whereas mass timber gives us a truly prefabricated structure. And better than that, it's manufactured, not just prefabricated. The delivery of the Forte project held for us a learning that probably should have been obvious, but really only crystallised when we were partway through the project. Namely, that we were prefabricating virtually the whole structure, and that readily enabled prefabrication of other elements. Because suddenly, for the first time, the building structure is precise, and it's decoupled into a series of discrete elements. And those elements can be made with automation using CNC, powered by CAD/CAM. And that opens the door to prefabricating other things like the bathroom units and the joinery and other parts of the building. And we're safe in the knowledge that those parts will fit when they're brought to the site without any site measurement having to be undertaken. And the image at the top centre of the slide, I think, speaks volumes to builders and project managers who've spent their lives knowing only one way to sequence the construction of a building. If you're used to conventional concrete construction, you'll realise that this is very unusual to see a modular bathroom sitting immediately under the leading edge of the structure, where normally we would find formwork and propping. And that really got us thinking about how much more could we not only prefabricate, but actually truly manufacture using the same CAD/CAM information, using automation. Because the closer we get to manufacturing, the closer we get to addressing those forms of waste. And I think this is where mass timber has a really tremendous advantage, because it's a highly workable material. And it's far easier to work with than other mediums. And CNC equipment works swiftly and accurately with very large timber elements. And larger timber elements have a huge advantage over small components, such as you might find when you're prefabricating in steel or concrete. Large elements mean a fewer number of crane lifts, and each crane lift, whether it's large or small, takes time to rig up and move and position. So larger elements equals fewer crane lifts, equals more time saved, less waste. And time is often talked about in relation to construction projects, but it's all too frequently not assessed properly in terms of its economic impact, particularly when talking to builders and quantity surveyors and project managers. And sorry to all the designers in the room, but you usually have no concept of time, so we'll leave you out of this equation. If you ask a builder to accelerate a project, he will generally quote you cost increases. If you tell him you have an amazing miracle product that could cut time by 30%, see how the argument goes to reduce his costs. But it's absolutely an argument worth having. And time will be reflected in the cost of the end product in two ways. Firstly, there's the direct time-related cost that we can obviously think of. Everything that is rented by the hour, the day, the week, or the month. So cranes and other equipment, people that supervise, insurances, even the site cabins that the workforce is sitting in. The longer it's there, the more it costs. Conversely, they cost less if you can go faster. But the second way is the time value of money. And this is obvious if you think about finance costs, the charges on capital. But perhaps less obvious is the impact on the quality of the investment. The measure that an investor will be using to assess the project in the first place. So simply put, if an investment returns the same dividend in a shorter time period, it is a better investment. And developers think in terms of recycling their capital. And capital is one of our supply constraints. So if we can deliver 3 projects in the time that it previously took to do 2 projects, we're definitely much happier. So you have to get into the detail and understand the productivity differences between your material choices. If CLT, for example, has a productivity rate, say 3 times greater than concrete, then the evaluation of the medium you build from must incorporate that time advantage. If you fail to understand that time advantage, I would compare that directly to looking at a bus ticket and a plane ticket and understanding that one's cheaper, but failing to recognise the inherent benefits of one mode of travel over the other. So recently we ran a hypothetical test case, and we did that on a 6-story residential building, which conventionally we would build in concrete in the Australian market. And we looked at what would happen if we manufactured that building using CLT as the primary structure. And because our model contemplates the reuse of standardised components, we gain significant time advantages even before the construction process starts, because our design process is shortened through using known solutions. The construction schedule has been calculated to be 40% shorter, and we have a total time saving in the development program of 30%. And I have to stress that this represents a very high level of prefabrication, and it doesn't solely rely upon switching to mass timber. But it's mass timber as the primary structure that is the key reason we're able to drive the extent of prefabrication we can. So the simplest way to measure the impact of time, the value difference between the plane ticket and the bus ticket, is to consider internal rate of return. And if you're unfamiliar with the concept of IRR, think of it as a qualitative measure on investment that takes time into account, whereas profit is purely a quantitative measure. And all public companies have IRR hurdle rates against which they assess their investment decisions. In the development industry, we might have hurdle rates somewhere between 15 and 20%, which is a great deal higher than most public companies, but that reflects the extent of risk that goes with property development. And so for an investment decision into a project to get a green light, we're looking for an IRR higher than our company hurdle rate. And if we go back to the test case I was talking about in the last slide, if a conventional project, for example, has an IRR of 15%, in our assessment, by prefabricating the project with mass timber, we can potentially see improvements of plus 16% for a total IRR of 31%, which is well above industry hurdle rates. Now, that might not be exciting news for many of you, but for someone like me who spent 20 years finding incremental improvements of 1 to 2%, that kind of result is spectacular and unprecedented. So what are we doing at the moment? At the moment, we have a mass timber project in construction in Sydney at Barangaroo, which is on the harbour front. This is a 75,000 square foot project over 7 levels. Construction started. The timber's on its way from Austria. It's due to arrive in 3 weeks. And as you can see, the building's wrapped in clear glass, so it very much showcases the timber inside and out. And I think the important thing to note about this is that this is an A-class building. It's on some of the most expensive real estate that you can find in Australia. And we've not yet put the building to market, but we've been inundated by blue-chip tenants and blue-chip investors wanting to take the building from us. In fact, we've decided to hold it back because the interest has been so strong, and that's not something you ever normally do with commercial buildings. You get them away as quickly as you can. What's interesting about the project, it was originally designed in concrete, and we'd already poured the foundations before the decision was made to switch it to timber. So it inherits a column grid that works okay, but it hasn't really been fully optimized for timber. And the second thing, which is a little bit challenging, is the construction team on this job is really approaching the building in a very conventional manner, and they're not planning to take a great deal of advantage of the time benefits they're likely to get from a prefabricated structure. And sometimes the construction team's the ones leading the innovation challenges, and sometimes they're simply being told to use the product, and I think this is a case of the latter. So what do we learn from that? Well, bringing new systems and approaches materials through any industry takes time, and this is no different. It's a much bigger change, however, than just switching from steel and concrete, because the design process is different. It has to be locked off much earlier. The fabrication process is different. It's being made by machines, not by humans. And the construction process has been changed to one of assembly on site, not really construction. So our way forward, having learnt some more lessons like that, is to rethink our operating model and examine the capabilities of our people, and also think about whether we need to adjust our organisational structure to take full advantage of this new way of working. And with that in mind, I'm very excited to announce the newest business in the Lendlease group, Lendlease Design Make. So in Western Sydney, we're establishing a manufacturing facility of 160,000 square feet, expandable up to 215,000 square feet. And we've put that together with a dedicated product design team, which at the moment stands at 18 people, on its way to about 30 people. And the purpose of this factory will be to machine timber elements from blank, unformatted stock into the specific components we require for our projects. So in addition to CNC capability in the factory, we've invested in an automated stud wall framing line. And we now have the capacity to add plasterboard and other finishing materials to enable us to ship to site completed floors, walls, facades. And we can also produce whole modules where a volumetric solution makes more sense. So that's in construction at the moment. That'll finish in October this year. We live in an age where innovation is king and disruption is desired. And if ever there was an industry ripe for disrupting, it is our centuries-old model of producing buildings. The Romans 2,000 years ago invented plumbing, and 1,800 years later the English invented low-cost steel production. Americans took that steel and created the first skyscrapers, enabled by the invention of the Otis brothers, the passenger elevator. And if you think about it, those were basically the last major disruptive changes in the property industry. And yes, I know, we have all kinds of other technologies. We have curtain wall, air conditioning, and intelligent building control systems, and passive house standards, and all those kinds of things. Many great incremental innovations, to be certain. But none of these have transformed the built environment the same way that plumbing, steel, and elevators have. Potentially, however, mass timber offers the next big disruption to truly make buildings easier, faster, cheaper, and better.